Great. Well, let's get going. Parish notice is if you have a question, please ask it as we go along, so you don't spend the whole presentation just sitting there thinking, oh, I wonder what that was. So let's get going. So thank you very much for having us today. I'm Rick Tyson, or Richard Tyson, and obviously Rick Booth. There we go. Sorry, the laptop wasn't working. Always good when it's recording. Couple of slides on who Schako are. We were founded in 1928 by Ferdinand Schad in Kolbinger, which is near Tuttlingen, which is in the very south of Germany, near Switzerland. The main factory is still there. Started as a manufacturing company, making surgical instruments, things like that. Needn't go through that. But we are a company that's led by engineers, not marketing or salespeople. So when you come across any of our literature, it's got all the information in there, everything you could possibly want, but it might not look the jazziest. More about that later. For instance, we have our own anechoic chambers for noise testing and airflow. When we give information, it's always in sound power, not sound pressure. So we may appear higher than other people in our noises, but that's the sort of data that acoustic engineers want. We have our own flow laboratory since 1974. Looks a bit Heath Robinson there, but it's not. It's set up to mimic particular rooms and room sizes if there's a specific project that wants looking at. So we do smoke tests, measure the air velocities, temperature differences at various stages on everything. We can do CFDs. We get involved in a lot of interesting projects. The Sphere in Las Vegas was one we were involved in last year. Fantastic opportunity with ME engineers. We did quite a lot of arenas with them. The CFD took about 4 or 5 weeks of computation by the computer to check out the results they wanted, but it was worthwhile because it all worked. So that's just to give you an idea of the engineering background behind us. Everything is tested in Germany, tough sad. So we know that if we say something, it will work, which is quite important. VAV is what we're talking about today, so variable air volume devices. They come under the air to water product library as such, which includes VAV terminal boxes, dual duct mixing boxes, used a lot in hospitals still, where you mustn't have water in a room, so you can control the temperature from main air handlers, chilled beams and fan coil units. We'll get the boring slides out of the way now. Legislation and guideline basics. There's 3 or 4 parts of the legislation that are relevant to what we do. British Standard 15251 is adaptive comfort temperatures. And this is basically that you can be very energy efficient. You can save up to 20% of your energy if you alter the set point between summer and winter. What's comfortable in the winter might be 18 degrees C. In the summer, different clothing regime, different expectations on the body, 24 degrees C could feel very good. And that can save up to 20% of your energy costs. Relevant for VAV because the airflow rates for heating and cooling may well be different. So if you've got a VAV system in there, it's got to be able to do both the heating and the cooling. And then that links to the diffusers you're putting on the end of the system, that they also must be able to cope with the different airflows. British Standard 13779 is basically almost out of date. It's that you had the biggest temperature difference to the smallest air volume and therefore the smallest builder's work. But that's being superseded to a large extent by the need to keep fan power levels as low as possible. Therefore, ducts are slightly bigger nowadays, taking out more builder's work, but the energy usage is less. This is important because going to the terminal, the grill or the diffuser can use up to 30% if it's badly sized of the energy of a system, if you're not careful. Last one, British Standard 7730 is that condition of the mind which expresses satisfaction with the thermal environment. In plain English, do you feel hot or do you feel cold? This is important when you're thinking about airflow and temperature differences going through the VAV systems to the grills. What's good for one person might not be ideal for another. We all have different thermal comfort zones. But so long as 80% of your occupants are okay, you should be all right. It's important to remember that people don't want to see, hear, or feel ventilation and air conditioning. It's a secondary thing to them. They want to come in, work efficiently, chat to their friends, do whatever they need to do, and go home. As long as they've got enough fresh air so they don't get headaches or sniffs and colds, they're not worried. Keeps the dirt out, and that's all they're concerned about. So let's start with a range of our devices. There's basically 4 types. There's CAV, which is constant air volume devices, and VAV, which is variable air volume devices. And they're either mechanical or electronic. The mechanical ones we tend not to use in this country. They're not super accurate and they need perhaps 50 pascals of pressure onto them. So quite a lot of pressure, more than a small fan coil will do to operate, because they work against a differential pressure and a spring. So we tend not to use those in this country. So we're looking at electronic devices for either constant air volume CAV or VAV. So have a look at the different types. There's the standard VAV unit, which is the top left rectangular one. Can operate between 15 and 100% of its volume. Works between 50 and 500 pascals. And you need one diameter or one diagonal of straight duct before the unit to ensure that you get a laminar flow of air. So the airflow is smooth, like a stream running nice and smoothly through that. So it can measure properly. There's the smaller one at the bottom left, which is the inline version. It's 5% accurate, plus or minus 5% throughout the range. BMS compatible. There is an ATEX option. We think we're the only manufacturer in the UK now that Trox have dropped out of making ATEX explosion-proof units. But the market is small, so it's a relatively small product. But our standard ones are the go-to for a lot of VAV applications. Top right is the compact unit. These are very useful if you're retrofitting old offices where all the system was designed for the air needs of the 80s, 90s and 2000s, where there wasn't such a demand for high air volumes. These units are about between 1/2 and 2/3 the size of the old units. They don't need a lead-in duct. They can go straight onto a bend. They're very quiet. They're built-in acoustics on them, and they can handle sort of 1.5 to 1.7 times the air of the old units, which means if you have to have more air in because people have PCs, they need more cooling, they're more crowded. There's more people crammed onto the floor plate than there used to be. It's an ideal situation for that. And then you've got the compact inline unit, which is the bottom right unit. That has a short body length for certain conditions, not quite so accurate, but in most applications that works fine. So let's start with looking at the compact units, the piano and the VAS. Operate between 10 to 50 degrees centigrade. Differential pressures as low as 20 and as high as 1,000. Differential pressure is the difference in pressure between the system pressure going into the unit and how much is needed downstream towards the grills. So if you need 50 pascals to do all the grills downstream, and you've got 100 pascals system pressure onto it, you've got a differential of 50 pascals across the unit. It's just to give it some authority so it can work. They work as low as 20 pascals on that. The air velocity through them is either 2 to 12 meters a second, anywhere between that for a VAV system. More on that later, why you might want to choose that. The EBE range, similar, needs a lead in. Thing with these is they're used where you have a main riser through a building. On each floor, you have a branch duct coming off onto the floor. They're ideal for that sort of situation. Relatively inexpensive and will set the air volume for the whole floor if needs be. This is the inline range. Again, these go up to 1600, 1.6 meters cubed per second, so they can handle a lot of air. They're used in the main ducts generally, can be acoustically clad if you want to. And the last one to look at is the VLV range. All the others use this measuring cross, which has 12 measuring points on it to ensure the accuracy of how it controls the amount of air going through the system. The VLV range uses a diaphragm and a venturi in there and measures the airflow through the venturi with pressure through the venturi and pressure in the open duct. It is ideal for doing very small volumes, used typically in laboratories, but it has other uses. It can go from sort of 3 to 600 litres a second, so very, very low volumes. It has a specific application, but is actually quite popular, especially in pharmaceutical, where you've got a pressurized laboratory, and you might have a personnel airlock, and you'll also have a machine airlock where they pass experiments through, and this will control the airflow that changes on that. So why use VAV? VAV is coming back into fashion, or it's come back into fashion. It can ensure there's the right amount of fresh air into a building, especially in meeting rooms or auditoriums. It can vary the amount of air depending on the people that are in there, for process cooling as well, things like that. You can use it on an all air system to use it to take out the thermal load to the cooling and the heating. There's no water coils in the ceiling, which means they're great for printing areas, operating theatres, things like that, where the last thing you want is a water leak. Usually work, oh gosh, sorry if you can hear something. I'm sitting underneath a polycarbonate roof light and it's absolutely chucking it down. You can use them as well for free cooling. And if you set them up properly, you can have the fan running at a very low static pressure. Where would you use them? You can use them anywhere, but typically meeting rooms, occasional use rooms like auditoriums and that, departure lounges in airports. There's no point having enough air in there for when it's a super crowded bank holiday, when it's a cold November Tuesday and there's 3 passengers there. So you can ramp down the air. It's used in laboratories, often linked to the fume cupboards. Fume cupboards doing the extract, the VAV does the supply. And you can have units that go from fully open to fully shut in 3 seconds. So if there's a catastrophic failure within the experiment, you can shut the air off really quickly. Used a lot in operating theatres as well. When you come to look at a unit, don't be fooled by the damper position. It's almost irrelevant to how much air it's passing because it's pressure independent. If there's lots of pressure, it'll be shut, almost shut. If there's little pressure, it'll be almost open. And that comes as part of the sizing process when you're selecting them for a system, is that you want to make sure that they are all operating as open as they can. So you size them carefully. There's a little slide about that later. Sorry. back end of a cold. When you're doing temperature control, you can have constant volume with variable temperature, or you can have variable volume with constant temperature. It matters not. The constant flow variable temperature works quite well when you've got a standard office and you know you've got a minimum fresh air requirement needed as well. This slide shows you how the measuring crosses work, and it shows you the air coming around the bend. It's lost its nice steady flow of laminar, and it takes one to diameter or one diagonal to get back to its standard flow. And there you can see all the measuring points that are used to ensure that the accuracy of the unit. This slide just shows you the minimum diagonals. Obviously, if you're using the piano or the VAS, you don't need that. So it's often specified in areas where there's very little room. This is the standard actuator that comes with the unit. It's Belimo. Almost every manufacturer uses a version of this actuator. The only thing you need to know as a contractor stroke designer is there's a 5-pin DIN connector there that you can plug the BMS into, or you can plug a little handheld tool to sort it out. There's a manual button on it, but more importantly, the little green light, if you push your pen into it and hold it, the unit will go from its set position to fully closed to fully open to back to that set position again and cycle through. So if you've got any doubts whether the unit's working or not, you've been called to site, someone's saying, oh, it's jammed, it's whatever, you can, ooh, what happened there? There we go. You can do whatever you want with it just by pressing that. The majority of times we get called or calls from site saying the unit's not working, it's simply that it either hasn't got power to it or the BMS isn't turned on yet. But if it's got power to it, you can at least see that it's working. Now the interesting bit, the rules of thumb, because they're the bits we all want to know. Terminology, V nominal, V maximum, V minimum. V nominal is known as V nom, and it's the volume flow rate through the unit at 12 meters a second. That's its maximum. V max is the volume you need to meet your design load. And V min is the smallest design load you need to meet. That may be because there's no one in the room. It may be because the cooling isn't required. And system pressure is the index of the air handler. So they're the things you need to know. When you're selecting these, and obviously we'll do it for you, but if you want to have a look yourself, the unit will go from fully open to fully closed. So it can stop all the air. You can have 1 meter a second of air going through it, or 12 meters a second. But that's going to be connected almost certainly to some grills. So think about whether the grills themselves can handle that turn down. The cold air may dump, the warm air may stratify, i.e. it hasn't got enough power to get from high level to low level. So it just sits like a thermocline on the ceiling. So you've got to look at selecting a high induction diffuser, something like an adjustable linear or a swirl, something like that. So it's linked to that system. If it's fresh air into a space that's going through fan coils, it doesn't matter, but it's important when you're looking at this, it's going on to diffuser, that's the case. So good design practice. Maximum velocity through a VAV, you can have 12. You get noise and pressure issues there. There's no reason why you can't have it though. We tend to design as a maximum of 8 meters a second and a minimum of 2 meters a second. That gives the unit authority, so it's actually got the ability to control against different pressures. And it means you've got somewhere to go. If your client says, oh, actually, I'll put another 20 people in that room, or you know, we've put more seats in the auditorium or the Spanish Steps, you've got somewhere to go. The Vmax is usually less than 80% of the V-nom, and the minimal is 25% if you're not heating, but it's 40% of the V-nom if you're using reheat. Reheat is on the rare occasions you've got to heat a battery after the VAV because you've only got cold air coming into it. It's not an energy efficient way of doing things, but often it's done just to trim little areas. And obviously the heater battery needs a minimum airflow across it before it trips out. So it's just something to consider if you're building up a system on that. Looking at the system pressure, I've jumped one, there we go. Check at the index in the first unit. This allows you to run the specific fan power as low as possible. This is just a typical example, not factually correct. You've got 500 pascals coming off of the air handler, 200 litres a second to floor, and the max noise you can have is 38 dBA. Full floor, 500 pascals, 200 litres a second. You need a size 5 piano at 38 dBA. Third floor, you've only got 400 pascals in this example, 200 litres a second. You can drop to a size 4 at 38. So the units, as they go down, tend to get smaller and quieter, because by the time you get to the ground floor, you've only got 100 pascals left. So you can actually use a size 3 and it's only 30 dBA. So it's important to consider all of this. Just because you've got a 10-story building, don't think the VAVs need to be the same size all the way through. When we're selecting for you, one of the things we look at as well on the selection software is where it's going onto a diffuser. We'll look and check that the airflow works for the diffuser. So as long as the airflow in what is effectively a psychrometric chart is in the green zone, everything is good. If it's in the red, chances are the air will stick to the top of the ceiling and not come down properly. And if it's in the blue zone, it'll be too cold and you get drafts and complaints. This slide shows the matrix of all of the VAV units we make as Schako. There's loads of them, which is why we always say, if you've got a VAV application, give us a call and we'll talk you through and we'll select the best one for you. There's many there. There's also another page of these that go with fume cupboards in polypropylene and have different ratings on them. I've heard no questions, so you've either both gone to sleep or we're all okay. Quickly look at the selection software. There's two versions. There's the full downloadable version or there's the online version. The online version is a light version, but it's really easy to do. It's on our website. You can click it anywhere and make it work. When you look at the downloadable version, remember we're engineers, we're not salesmen. So it gives you all the possible information, sound power, volume, anything you want, but it's a bit clunky. So I'm just going to whiz through these slides. Shows you a VAV unit. You enter in what you want as your Vmax and Vmin, 1400 and 800. System pressure, 150 pascals. You look down the line, you'll see at the top it gives you the flow noise in mid-range frequencies and the radiated noise, so you can make your own judgments as to what unit you want. So you might select that one, that's the best option, or even that one. If it's a piano, slightly different one. When you come to look at the grills, different temperature differences, obviously the air doesn't go as far along the ceiling if it's cold, so you might want to look at that and increase it. That is basically the VAV. Any questions for you, please?